So I'm going back and I'm doing a problem that we had done before. This had to do, we talked about this a little bit yesterday. You had these particular baseball cards. Oops, that one's not even on. It'll come up in a sec, I hope. There we go. You have these baseball cards. You went out and you bought yourself 40 boxes of this particular cereal it came with. And if I just gave you this, 7, 6, 9, and 7. Hey guys. If I just gave you that, this was what we observed. Okay? So, if we just had that as our given, then we might have to say, well, we would expect that we would have gotten 8 of each card because they're equally distributed. Okay? So that's the first thing that you would have to walk through on this. And then it's relatively easy to do the chi-square. So the chi-square just basically is going to be, the chi-squared equation is observed minus expected quantity squared over the expected. So if I went through each segment of it, I would get 11 minus 8 quantity squared over 2, and that would give me 0.125 or 1.125. And then if I did 7 minus 8 quantity squared divided by 8, that's going to give me 0.125. And then if I did 6 minus 8 quantity squared divided by 2, that's going to give me 0.5. And then if I did 9 minus 8 quantity squared divided by 8, oh, that should have been 8 right there, sorry. That would have given me 0.125. And then the last one would be if I did 7 minus 8 quantity squared divided by 8, that's going to give me 0.125. If you add all these up, this gives you your chi-square that you plug into Desmos. In this case, it's just going to come out to just 2. Okay? So this will be something that we will plug in to Desmos. Okay? And then what we have to do from here is we have to look at, our, let's see, where can we go with that? What we could do is our null hypothesis could say cards are equal. Our alternative, cards are not equal. Okay, as far as being distributed. Then we'd have to look for our degrees of freedom. And in this case, our degrees of freedom is just going to be based off this. So we have 5 outcomes minus 1. So our degrees of freedom on this is going to be 4. So that's another thing I'm going to plug into. Desmos. So if you go on to Desmos on the one on Schoology, and the one on Schoology is the only one you'll have to use. As we get there. So in that case, everything I've written on that problem so far, finding out kind of the chi-squared and stuff like that will be something that you'd have to show on the test tomorrow. And then let's see, we got chi-squared calculator. And we said degrees of freedom was 4, which we are at, and then the chi-squared is going to be 2. So our p-value in this case is 0.74. Okay? So our p-value, oops, I want to use a pen. Our p-value is 0.74. Okay? The default p-value, if it's not given, or if the alpha value is not given, is we're looking for things that are less than 0.05. Okay? Obviously, 0.74 is bigger. So because 0.74 is greater than 0.05, I should be able to write a little nicer than this, we are going to fail to reject the null. Okay? And we did not have evidence or strong evidence, did not have strong evidence against the null. Squeeze in there, evidence against the null. Okay, so that'll be definitely a type of problem that you'll see will be either on the front or the back. Okay, is there anything about that particular problem that doesn't make sense entirely? Yeah.
So for the degrees of freedom, is the 5 from the observed?
Yeah, I had 5 pieces of observed data.
Okay.
So I didn't have to go by the actual table where the degrees of freedom are the rows -1 times the columns -1. Okay, so that's why I wanted to make sure I showed you this, because this will happen on one of the sides, one of the problems tomorrow, okay? All right. All right, I'm going to make up a completely fictitious problem. And this data has nothing to do with anything. Can I move off the screen? Okay, so let's say we are comparing the US to, Mikey, pick me a country that's not the US. England? Okay. Okay, we're comparing US and England. Okay. And we're going to talk about like the net worth or the family income of a $150.01 to 200,000 plus. Okay, and again, this is just made up data, but let's say it was a random sample that had taken place. So let's say we had selected people. So the green is the important part. Okay, that's what's going to define our degrees of freedom, because it'll be the green rows, there's 2 of them, -1, times the column rows, which is 3 minus 1. Okay, now we have a total that's going to take place over here. Hey, Bob. So this, if I go 10, 40, and 30, that gives me 80. If I go 30, 20, and 10, I get to 60. 60 and 80 add up to 140. And then 10 plus 30 is 40. 40 plus 20 is 60. 30 plus 10 is 40. 40 plus 60 plus 40 is also 140. All right. So in this particular case, we want to see, we would want to see that our thing, this might be a word problem in a way that it would say, we could call mu the income of US versus England. Okay, and again, this is totally made up. So our null, we could say that mu is equal income, or no, let's not do that. Let's do independent, dependent. We'll call that independent, and the alternative is dependent. Okay. So things that we can go from this, and you're going to be expected to know how to do this. So make sure you see how I do it. I'm going to try and do it in different colors. I need to figure out what the expected value would be. Okay. And so what I'll do is right next to each of the numbers, I'll put the expected value. So if I was looking right at the 10, I'm going to go 80 times 40 divided by 140, which is, so expected value is 22.9. If I wanted to find the next one, I'm going to go 80 times 60 divided by 140, and that comes out to 34.3. And then I'm going to go 80 times 40 divided by 140. And so that's also going to give me 22.9. And then I'm going to get 60 times 40 divided by 140, which that's going to give me 17.1. I'm going to go 60 times 60 divided by 140. And that's going to get me 8.6. And then I'm going to go 60 times 40 divided by 140. And that'll also give me 17.1. Okay, so the black are the expected values. Okay, that's a decimal right there. 22.9. Okay, the expected value is not the chi-square. Make sense? This just basically means if I were to pick another arbitrary random sample of 140 people from the US and England and figured out what their yearly income would be, the black values are my expected values, what I expect that would take place from doing this multiple times. Okay, so from there, I'm going to find chi-squared. So remember, chi-squared is going to be the observed minus the expected quantity squared divided by 2 all over the expected. Okay, those expected values are what you're getting from above. Okay, so if I went up to the US and up to 100,000, you observed 10, but you expected 22.9. Come on down. So if you were looking at your chart, you observed 10, and your expected was 22.9 quantity squared over the expected. So the first one, if you did the math on the calculator or on Desmos, doesn't matter where you do it. This first one is going to come out to 7.3. Oh, come on. Okay, that's going to be chi-squareds. And if I go through each of those iterations, which you'll be asked to do, so the second one would be I observed 40 minus 34.3. Come on, come on. I'll do decimals in a second. 34.3 quantity squared divided by 34.3. If you did that math, you're going to come up with 0.9. And then I'm going to go 30 minus 22.9 quantity squared divided by quantity squared divided by 22.9. And that's going to give us 0.22 or 2.2. And then just keep going through it. So then the next one you observe 30 minus 17.1 quantity squared divided by 17.1. If I did that math, I'm going to come out to 1, 2, 3, 4, 17.1. Oh, wait. Hang on, I redouble check my math. It's going to be, there we go, 9.7. That's going to give me 9.7 right here. And then just keep going through. So I got 20 minus 8.6 quantity squared divided by 8.6. That should give me, there too, clear, 20 minus 8.6 quantity squared divided by 8.6. It's going to give me 15.1. Boy, I made errors on this like crazy. 15.1. Just that's a 17.1. 17. And then my last one is going to be 10 minus 17.1 quantity squared divided by 17.1. That's going to give me 2.94. 2.9. Come on. 2.9. Okay. Now at this point, you want to add up all the purples. And that's going to get you your chi-squared sum. So I have 7.3 plus 0.9 plus 2.2 plus 9.7 plus 15.1 plus 2.9. So this is going to come out to 38.1. Because it's so large, if you get a number bigger than 20 on the chi-squared slider, just use 20. Okay, unless you modify the chi-square. Okay, it's far enough to the right, it should impact it. And then my degrees of freedom. I have 2 rows minus 1 times 3 columns minus 1, which is going to give me 1 times 2. So my degrees of freedom is just 2 here. Okay, now we should be able to use our chi-squared. Okay, so we have 2 degrees of freedom. Oh my, come on. Stop. And then chi-squared 20. All right, so that comes out to like 0.0045. Is that pretty close to 0? Okay, so we would be safe to say on this that our p-value is close to 0. If I did not give you a p or an alpha, your default is you want p to be less than 0.05. Is 0 less than 0.05? This week, yes. So we are going to reject the null. And then basically you could say that we found, so this is where your answer lives. And this, we found evidence. We found actually strong evidence against the null. Okay? So the first one I gave you was a fail to reject. This one is a reject. Agree? This video. Then when they asked you, is the sample large enough? I mean, you basically know your rules. You want things bigger than 30, right? So those are just some things that keep in mind when you're doing it. Okay, I'm not going to go into the schematics. The only time you would say, is our thing big enough? Is our values big enough? The only time that would really go into play is if the original 10, 40, 30, 30, 20, 10 of our observations, let's say we were getting some really large values, but one of the values was like so tiny compared to the rest. That's kind of where you get a little bit of a red flag, but I'm not sure if you're going to see that, but just so you know. Okay, so that's all videos.